Okay, Joe, so I'll be doing this through my computer because it's easier and it's 100% that it will come up upright rather than the wrong way with the mobile. I'll go through what I said yesterday just as a benefit for you, but if you've managed to see the video, you can skip part of this video, and then I'll go through the heat settings, which is mostly what I wanted to show you. So this would be the home page. We've already seen this in another video or another image that I've sent in an email. Essentially, we have the unlock and the lock here. So pressing that would lock down the panel, and you won't be able to touch anything from here, at least the building manager, but an administrator, someone like you, can easily go here, put in the password. For now it's 1234, and you have access to the system. You can change anything within the panel. The same applies as with Revision A. For example, with a locked panel, the compensator is still accessible for the building manager. Down, basically, we have, in terms of settings on the dashboard, we have the compensator, which we can change. For example, going from -2 to 5. The mode, we have auto, valve set, manual, and off. Okay. If we had to go valve set, we can put open or closed. With the case of manual, you basically just put in the position you want, press OK, off, and auto. Also, all the inputs inside the panel, for example here, if I had to write 630 and press OK, I would get a warning saying motor manual position should be between 0 and 100. So in this case, I need to set it to 63. Let's leave this as auto for the time being. We have the inputs here. Obviously, these are shown based on what the panel is reading, and then we have the outputs here. Anything which is auto is obviously controlled by the panel. Anything which is manual, we can control from here. If we want to switch to auto, we basically switch to auto, and then the panel is controlling that particular input. Now, going to the heat settings page. First and foremost, what I would like to do here is to sort of put things in much clear perspective. We have the graph below, okay, showing how the motor will adjust or will output. Okay, the red shows the linear control, and the blue shows the linear and the exponential combined. So remember, the panel will always output the blue here. For now, I'm just going to put both of these values as 0, which are of the exponential. So we essentially have just a linear control. Okay. One small thing, as you could see here, mild weather day is 70, but because of a graphing error here, you would think that the motor will start opening by 72. That is not actually true, because the problem is that the graph is, basically pointing one at 68 and the other one at 72, and the 70 is not graphed in between. So you get sort of this little graphing error, but I don't think it should be that much of an issue. We also have day and night. So right now the settings are 70 and 55. This is the day, and if I had to press on night, I would see the night output. Okay. Changing any value, obviously, let's go to, for example, 68 here, would change this one. Let's just go a little bit further down, and that would have an effect on the day, obviously, part of the graph. Same go with valve feedback sensitivity. Okay, 20, etc. So for now, I'm just gonna go back to the settings I had. I was working with these. Now let's come to the exponential curve and the exponential sensitivity. I made a small change on the exponential sensitivity. The way it was quite difficult to design a graph. So the way it works now, exponential curve is very similar to the way it was. Essentially, it designs the curve for you. So let's start by increasing this to 10. Okay, so now I have this graph. For now, do not worry a lot about where the graph is starting to sort of pop down, let's say. This is something we can adjust. What we need to do is we need to change with the exponential curve is what I call the rate of attack. Okay, so let's start with a very small rate of attack. Okay, this is a very small rate of attack. As you can see, it's going down very slow. Let's come up with something more aggressive, you know, going to 20. So as you can see, the rate of attack is very harsh. Okay, so exponential curve essentially designs this kind of attack on the graph. Now let's say that this is something comfortable for me. Okay, what the exponential sensitivity does, and again, probably we would need to change the name here. Rather than exponential sensitivity, this should be exponential application starting point or something like that, but maybe we can find a name as we go along. Basically what it's going to do is shift the graph up and down. So it will shift it going up and down. So in this case, let's say I'm more comfortable with this graph, but I want this exponential to start to come into force when the temperature is 28 degrees Fahrenheit. Otherwise, I will want the graph to follow basically the linear approach. So what I do is I increase this, let's say, to 10. As you can see, the graph is now closing down and coming up towards the linear. It's still a little far away, so let's try 20. It's nearly there. Let's try 25. Okay, and I think this is okay. I mean, you could play maybe a little bit more, 30. Yeah. So as you can see, the rate of attack has not changed. What has changed is that I've closed the graph up so that it starts applying at 28 degrees Fahrenheit. If I want to increase again the rate of attack, maybe I start a little bit more aggressively. Let's try 20. Okay, so as you can see, it's the same. It will start again in the near 28 degrees Fahrenheit, but it will apply a much more attack towards the exponential. So it will allow the valve to sort of settle down and not close as much, more. Again, if you want to reduce this attack, you can go to 15, and now the valve will not, back off from opening that much. Okay, I think this is a much better way to design it. Again, the exponential sensitivity simply shifts when the exponential becomes active. So if I had to reduce this to 15, again, it will start applying the exponential at a much more, let's say, much more quicker when the temperature is going down. Again, exponential sensitivity is not the right name. Probably is exponential. This would be exponential attack, and this would be exponential application, or something like that. We'll have to look at these two parameters. For now, I just left them as they were, but I think this is much better to design an output for your motor than it was before. Again, we have day and night, so we can see how the system is going to work, or how the system is expected to control the motor between day and night. I'll leave it to you to provide me some feedback.